Hi everyone, welcome to Inorganic Chemistry CHM 577, and for today's lesson we are going to discuss and also learn about metallic bond. Okay, so this is a part 1, so we will focus on the introduction of the metallic bond. Okay, so metals in the periodic table are found at the left and also center of the periodic table. So as you can see from this slide, okay, so this is where we have the metals, and also at the right side of the periodic table are actually the non-metals. Okay, so metallic bond is actually formed between atoms of metallic elements, and the electron cloud around the atoms arises from the sea of donated valence electrons. It could be 1, 2, 3 from each of atom. So what happened here, the attractive force between the electron cloud and the positive ions will form what we call metallic bond. So in this diagram, it shows you the sodium, okay, where it has the positive ions and also the delocalized electrons. So the attraction, or what we call attractive force between these two, the positive and also the electron, valence electron, will form metallic bond. Okay, how does the metallic bond can be formed? So first, atoms of metals are tightly packed together in a giant lattice similar to the lattice in ionic compounds. So this is what we have discussed previously, where we discussed about the covalent and also ionic compounds. So the outer electrons separate from their atoms and become delocalized, so creating a sea of electrons. So as you in this diagram, so we can see the metal ions, okay, and also the sea of free moving electrons, or delocalized electrons. So these atoms become positive ions, alright, the brown ones, they become positive ions and are attracted to these electrons, the smaller one. Okay, and then this attraction is calling metallic bonding, and this is the reason why the positive metal ions do not repel each other. Alright, so let's go to the properties of metals. Okay, so metal ions form a lattice which is more tightly packed and denser than the lattices in ionic compounds. So they form crystal that we call it as grains, right? So metals generally have a very high melting point and also boiling point, because the metallic bonds are very strong, and also a large amount of energy is needed to break them. So metals are also good conductors of heat, because it has a free moving electrons that can take in the heat energy, so which makes them move faster, so they can transfer the energy throughout the lattice. And the fourth one, metals are good electric conductor, because the free moving electron or delocalized electrons can carry an electric charge. Okay, so I have a scenario here. Silver is the best conductor of electricity and copper is the second best, but why is copper used instead of silver for electrical wires? So this one we will discuss during our class. Alright, so after the properties of metal, let's go to the strength. Okay, so metals are usually tough, as you know, and also not brittle. So when when a metal is heat, the layers of the lattice just slide over each other, and the metal bonds do not break because the electrons are free to move. So in this diagram, we put pressure, okay, or force here. Okay, so what happened here, from this the layers of the lattice just slide over each other and become like this. Okay, alright, so this means that metals are, first, they are malleable, so they can be bent and also pressed into shape, and they are also ductile, so they can be drawn out into wires. What is actually the main factor that affect the strength of the metals? Okay, so the main factor is the metal grains. Okay, so layers of atom can slip over each other in metal grains when a force is applied. So, but this slippage stops at grain boundaries. So here, okay, this is the grain boundary. So where one grain meets another. Okay, so when the layers move, when the atom layers move, so when this atom has a smaller grain, okay, usually it will move at shorter distance. So this means that metals with smaller grains are usually stronger and harder than metals with larger grains. So the faster the molten metal is cooled, the smaller the grain size. So we can actually modify or alter in this size of grains, okay, based on how fast the molten metal cool. Alright, so how to strengthen the metals? Okay, so metals can be made stronger by adding another element. So when the metal is molten, so the atoms of the new element spread through the crystal structure. Okay, so in this diagram, if you look at this blue blue atom here, alright, okay, so we put force, okay, at the right and also left side. So because the atoms of the added element are larger, alright, this one, they make it difficult for layers of metal atoms to slide. So this makes the metal less malleable and less ductile. Alright, so this process is called alloying, and the new substance we call it as alloy. So that's all for part 1. So I'll see you guys at part 2, where we will discuss more on the electron cloud or electron sea model. So I'll see you in part 2. Bye!